we're building and backtracking with flowcharts, and you can see here we've got some flowcharts with some empty squares and we've got to fill them in. And what we do is we start here at X and we multiply by 2. You can see the arrows tell us to go to the right, and that would be X times 2. And you should know by now that we call that 2X. Then the next step is to add 7, and that expression would be called 2X plus 7. Next we have a series of boxes and 3 steps. We're still starting with X, so we start here and you can see there are 3 steps we've got to go to the right. We start with X and we've got to divide by 3. Now you could write X divided by 3, or it often is easier in algebra to go X over 3. It means the same thing and it tends to work better a lot of the time. Next we have to get what we had previously and then add 4. So to keep it together, this expression, this term we just had is called X over 3. We need to keep that together, and sometimes you can use brackets. That's optional. You have X over 3 plus 4. Next, we multiply all of that by 6. So we had X over 3 plus 4. We have to times all of it by 6. Now if we put a 6 right there, it only times the X over 3 by 6, and the plus 4, poor old plus 4 is left out. So again, we have to use a grouping mechanism, brackets in other words, and we can go 6 outside of. Remember, the times sign doesn't have to be used in algebraic terms. In the next example, we have to convert that to flowcharts. So we have this expression here, 3 outside of X divided by 5 plus 6. We have to turn that into a series of flowcharts. So if you think about the example just above, we started with X, we divided by 5, we add 6, and we times by 3 would be the order if it was like the question we just saw. Rewind the video if you need to see that previous one again. So we would start with X, and then in the next box we need to have X divided by 5, or X over 5. How did we get from there to there? We have to divide by 5. So we also need to put in what we did. So we divided by 5. You see that's been added in there. Next we look at the expression. Remember, we're working inside the brackets, and why are we doing that? Because brackets put things first, they prioritize things. So we're not going to deal with the times 3 yet. We have to deal with everything in the brackets, and the next thing would be plus 6. So we would end up with X divided by 5 plus 6. How do we go from there to there? We simply added 6. Lastly, we have to times by 3. You can see the 3 outside to get the final expression. So let's write that in. 3 outside of X divided by 5 plus 6. What did we do with the previous step? We multiplied by 3, so we write that step up there. Okay, so we've built it. How do we backtrack it? And what is backtracking? Well, backtracking is simply going backwards and doing the opposite thing. It's basically what you do when you're solving something. So let's look at this example here. And we start with X, something happens, we get something, and then something else happens, and we've got our final expression, 2 outside of X plus 7. Well, something must have been done inside here first because it's got brackets on it. So it would have been the x plus 7 would have occurred next because of the brackets. So what happened? We added 7. To get the final expression there, 2 times x plus 7, we have to multiply the previous result by 2. So that's very similar to what we've been doing above. However, what about these other arrows down here, going the other way? They're the backtracking arrows. And basically we have to use what we looked at in the previous video, the inverse operations. What is the opposite operation to plus 2? Is divide by 2. So we have to divide by 2. Let's see, 2 times x plus 7, divide by 2 undoes the times 2, and it just leaves the x plus 7. So that makes sense. We have to, in the next step, undo the plus 7 because it's going the opposite direction with a minus 7. Alright, so we divide by 2, and then we minus 7, and x plus 7 minus 7 leaves us with just x. That makes sense. Lastly, we have a puzzle. I'm thinking of a number. If I multiply it by 5, and then I add 6 to my answer, my answer is 21. What is the number? I will call the number m. Alright, well, this could be done with trial and error, but in maths we're trying to teach you how to use more efficient methods, so this method will suit simple equations like this or simple situations like this. It will also suit the much more complicated ones you'll see in the future. So let's learn the proper efficient way. Okay, part of it's been done for you. Let's see how they got these things. It says I'm thinking of the number, I will call the number m. So that makes sense that we start with m. And I multiply it by 5. So you see the multiply by 5 and we get the result 5m. Then add 6. Alright, so after that we add 6. So the previous result plus 6 is 5m plus 6. So what's new? The new thing is there's an answer. Hallelujah, there's an answer. Alright, in the previous ones we just had expressions that didn't go anywhere. We've actually got an answer here. So the answer is 21. Oh, there it is. Now notice how what we do there compared to what we saw above where we just had single decker flowcharts. See those? You've got now a double decker. So there's an answer. How do we get to the number m? Well, we've got to head back to our left. That's why it's called backtracking. We've got to go back there. And our final answer will end up underneath m because that will be the answer, the result to m. That's when we solve for m. So remember from the previous one, plus 6, the inverse operation is minus 6. We go 21 minus 6 is 15. The inverse operation next of times 5 is divide by 5. Let's divide by 5. We go 15 divided by 5 is 3. So the result is 3. So let's check that out. I'm thinking of a number. Let's test it. I'm thinking of a number. If I multiply it by 5, that's 15, and I add 6, my answer is 21. You betcha it works. So we can check our answer with those by testing it. So this is called backtracking, and it helps us understand how to solve equations by solving it in the correct order, because sometimes students get the order wrong, and I want you to get it right.